Welcome to the DIY Honda Garage channel. The DTC P1193 indicates an issue with the fuel tank pressure FTP sensor circuit in Honda Civic models from 2006 to 2011. This diagnostic trouble code signifies that there is high voltage detected in the circuit. The FTP sensor is crucial for monitoring fuel tank pressure to manage evaporative emissions effectively. Its location is generally found near the fuel tank, linked directly to the powertrain control module (PCM), responsible for vehicle performance. High voltage signals associated with the FTP sensor can lead to performance issues or increased emissions. Before proceeding with any troubleshooting, it's vital to collect all freeze frame data and onboard snapshots to get a comprehensive understanding of the vehicle's condition. This will aid in accurately diagnosing the problem. The fuel tank pressure FTP sensor is primarily responsible for detecting the vapor pressure in the fuel system to ensure that evaporative emissions remain within allowable limits. This component plays a vital role in the vehicle's emission control strategy by assisting the PCM in managing fuel vapor and preventing harmful emissions. In terms of location, the FTP sensor is typically found mounted on the top or side of the fuel tank, making it easily accessible for troubleshooting. Its direct connection to the PCM means that any irregularities in its readings can significantly affect vehicle performance, fuel efficiency, and emissions. The high voltage, indicated by DTC P1193, suggests that the sensor is sending abnormal signals, which might lead the PCM to misinterpret the fuel system's status. Therefore, accurate diagnosis is crucial for ensuring compliance with environmental regulations and vehicle performance. Several factors can contribute to the generation of DTC P1193. Firstly, poor connections in the circuit could inhibit the reliable transmission of voltage readings from the FTP sensor to the PCM. This might happen due to corroded or damaged wiring. Secondly, loose terminals can disrupt electrical continuity, leading to intermittent signals or erratic voltage readings. These loose connections may not always be visible and often require a thorough inspection to identify. Lastly, a faulty FTP sensor itself could be at fault, either due to internal failure or wear over time. Identifying the underlying cause is essential, as it directly impacts the resolution process and the overall vehicle performance. A systematic approach to diagnosing these potential issues will aid in isolating the problem and restoring proper functionality. Symptoms associated with DTC P1193 may include a check engine light activation, indicating that the PCM has detected an issue within the FTP sensor circuit. Additionally, drivers might notice poor engine performance, as the system relies heavily on accurate pressure readings to optimize fuel delivery and emissions control. Without this, the engine might respond sluggishly or exhibit lower power output. Increased emissions can also be a direct result of high voltage readings, as incorrect data may lead to improper fuel mixture adjustments, eventually causing the vehicle to fail emissions tests. Understanding these symptoms is crucial, as they provide insights not only into the severity of the issue, but also into the urgency of the required repairs to ensure compliance and maintain vehicle efficiency. Begin the troubleshooting process by turning the ignition switch to the on position, which powers up the vehicle's electronics without starting the engine. This step is crucial for checking the FTP sensor voltage using the Honda Diagnostic System, HDS. With the HDS, observe the data list for the FTP sensor's voltage reading. The threshold for concern is around 4.61 volts or higher. If the reading meets or exceeds this value, this confirms a potential fault within the circuit and signals the need to continue troubleshooting. If the voltage is below that threshold, it suggests an intermittent failure, indicating that the system may be functioning correctly at the moment. Therefore, it's essential to check for any poor connections or loose terminals at both the FTP sensor and the PCM, as these could be causing temporary disruptions in voltage. Next, turn the ignition switch to the lock position to ensure safety while you work on the vehicle's electrical components. After that, disconnect the 3P connector from the FTP sensor to isolate it from the circuit. Next, using a jumper wire, connect terminals number 1 and number 3 on the FTP sensor's 3P connector. The purpose of this step is to bypass the sensor temporarily, allowing you to test if the circuit itself is functioning correctly without input from the sensor. This maneuver is essential in revealing whether the fault lies within the FTP sensor or the wiring and connections to it. Proper execution of this step will enable accurate measurement of voltage readings later. With the jumper wire in place, turn the ignition switch back to the on position. This step allows you to monitor the FTP sensor's voltage again with the HDS. Check the voltage in the data list. If the reading is 4.61 volts or more, this indicates that the electrical circuit is functional, and the issue likely resides within the FTP sensor itself. Alternatively, if the voltage drops below the specified threshold, this could suggest a problem within the wiring or connections to the sensor. Identifying the exact nature of the malfunction here is crucial, as it will guide the subsequent steps to either replace the FTP sensor or investigate the wiring further. Turn the ignition switch back to the lock position to safely remove the jumper wire connected to the FTP sensor 3P connector. It's crucial to conduct this step methodically to prevent any accidental shorts or interruptions in the circuit. Then, with the jumper wire removed, start the ignition switch again to on and proceed to measure the voltage between terminals number 1 and number 2 on the FTP sensor connector using a multimeter. This measure will help determine whether the circuit is producing the expected voltage levels. A reading around 5 volts suggests that the circuit is functioning properly, while significantly lower readings may point to a wiring issue or a problem with the PCM. Accurate voltage measurement is essential in diagnosing components effectively. After making necessary repairs, it's vital to conduct a final verification to ensure that the issues related to DTC P1193 have been resolved. Begin by verifying that any replaced components, such as the FTP sensor or wiring connections, have been correctly installed. Once everything has been checked, clear the diagnostic trouble codes from the PCM using the HDS. After resetting the system, it is crucial to monitor for any recurrence of DTC P1193. Conducting a test drive is recommended to simulate normal operating conditions and ensure that the vehicle performs effectively without triggering any error codes. This step not only confirms that the repair work has been successful, but also reassures that emission systems are operating within normal parameters. The importance of this verification process cannot be overstated, as it ensures that the vehicle meets performance and emission standards. To prevent issues like DTC P1193 from occurring in the future, implementing a proactive maintenance plan is essential. Regular inspections of the FTP sensor and its connections should be conducted, especially if the vehicle operates under harsh conditions. Cleaning or replacing corroded terminals and ensuring tight connections can help maintain optimal performance. Furthermore, utilizing high-quality replacement parts is crucial when repairs are necessary, as inferior parts may lead to recurring issues. Regularly monitoring the performance of the FTP sensor will also allow for early detection of any problems, minimizing the risk of more significant malfunctions later. establishing a consistent maintenance routine enhances the longevity of vehicle components and assists in preserving overall performance. In summary, understanding the role of the fuel tank pressure (FTP) sensor and its connection to the vehicle's performance is vital when dealing with DTC P1193. Accurate diagnosis, guided by systematic troubleshooting steps, will isolate the issue, whether it resides in the sensor, wiring, or connections. Addressing these concerns promptly not only improves vehicle function, but also ensures compliance with emission standards. Regular inspections and preventative maintenance will significantly reduce the likelihood of reoccurring issues and assist in prolonging the lifespan of critical components. Ultimately, being proactive about vehicle care will lead to better performance, enhanced safety, and long-term reliability for Honda Civic owners. Please like and subscribe to the channel. See you next time.